This is Pre-Calculus 12, Chapter 3.2. We're going to be continuing our look at transforming graphs. We're going to look at a special case. We're going to be looking at reflecting. This is the A and B coefficients. And we're just going to be looking at substituting in -1. Y equals negative f of x is a reflection on the x-axis. And recall that reflecting on the x-axis, we're flipping this way. Y equals f of negative x. That's a reflection on the y-axis. And we're reflecting this way. And over time, you'll just see this quickly without referring to your reference sheets. Plot g of x equals f of negative x. We look up here, and that's a reflection on the y-axis. So we look at the key points. We're reflecting this way. 1, 2, 3, 4, 1, 2, 3, 4. We're reflecting horizontally. 1, 1. And copy the curve as best as we can and label the curve g of x. We look at the domain of f. We start at -4 and we go to -1. And for the range, we're going down 3 and we're going up 4. Same as last time, we can ignore the graph. We can strictly look at the domain and do the transformation given this requirement. Since we're doing a reflection on the y-axis, only the x values change. The x values. The y values don't change at all. So what we do is we swap and negate. Okay, so we swap the -1. That comes over here. It becomes positive because we're negating it. And we swap the -4 and we're negating it. It becomes +4. And the range remains unchanged. We check over on the graph, and that's the case. We go from 1 to 4 and -3 to 4. So in general, we negate the domain and the range is unchanged. Here we have a special case. If f of x equals f of -x, so if the image matches its reflection on the y-axis, we call this an even function. An example of this is f of x equals x to the power of 4 plus 6. And to test, we just substitute. So f of -x equals, and we substitute with brackets, -x. So we're substituting a -x for an x. Okay, and we can simplify this. We factor out a -1, and we keep the power. And -1 to the power of 4 is +1. So we have x to the power of 4 plus 6, and that equals f of x. So this function is even, and just a note, substitute with brackets. Let's look at our next example. Plot g of x equals -f of x. This is a reflection on the x-axis. So we look at our key points here, and we reflect it on the x-axis. So 1, 1, 2, 2. And we copy the curve as best as we can. Let's try to get a key point here. It's not on a grid point. This is about 3.4. So 3.4 is roughly there. So we want to try to go through there and up to there. So the domain, we have -3 and we have 4. -3 to 4. The range, we're going from 1 to about 3.4. So if we look at the graph, our domain does not change when we're reflecting on the x-axis. However, the range is negated. So again, we need to swap and negate on the range. So we leave the domain unchanged, -3 to 4. And we need to swap. So this 3.4 comes to the front and we negate it. And the 1 goes to the back and we negate it. Swap and negate. So in general, we negate the range, the domain is unchanged. Let's look at another type of reflection. This is a double reflection. We have g of x equals -f of -x. So we're reflecting on the x-axis and y-axis. So we take this point, reflect it on the x-axis, then reflect it on the y-axis. We take this point, we reflect this on the y-axis, it remains unchanged, and then reflect it on the x-axis. Take this point, reflect it on the y-axis, then reflect it on the x-axis, and we connect the points. And if you notice the shape, this is a rotation of 180 degrees. So we look at this point, it's rotated 180, and we look at this point and it's rotated 180. Let's look at the domain. We have -3 and 2. And the range, we're going from -3 to 1. So we have to swap and negate both the domain and range. Swap and negate both. So the 2 comes to the front and we negate it. And the -3 comes to the back and we negate it. We take the 1, move it to the front and negate it. -3 to the back and negate it, and we get 3. So in general, negate both the domain and range. Here we have another special case. If f of x equals -f of -x, then we say the function is odd. An example is f of x equals x cubed. We can verify this by substituting. Okay, we have to put a negative out front, and then we substitute with brackets a negative x cubed. So we have 1, -1. We have -1. We factor out a -1 with a power, and we have x cubed. So we have -1 to the power of 4, and we have x cubed. -1 to the power of 4 is just 1, so we just write x cubed. And again, for this portion, we want to substitute with brackets. Okay, and technically f of x needs to be substituted with brackets as well. But since f of x is only a single term, we don't need brackets. But if there were multiple terms in here, we would need brackets around f of x. Okay, and the easiest way to reflect a function is plot the function if not given, and reflect the key points or grid points on the x and or y axis, and draw the curves between the key points. And draw the curves between the key points. Okay, let's look at some properties. Reflect f of x on the y-axis. Find g of x for this reflection. Okay, if you use your calculator, you'll get that. And we want to ask the question, where does f of x equal g of x? And is this always the case? And we can show this through algebra. So g of x equals f of negative x. That equals, we want to substitute with brackets, negative x minus 2 cubed minus 4. That gives us negative x minus 2 cubed minus 4. And we want to check that algebraically. And to check this algebraically, we want f of x equal to g of x, which is this. So do the algebra and check it and see if this is always the case. Okay, reflect f of x on the x-axis, find h of x for this. We don't always have to use g, we can use another one, h of x equals negative f of x. That's negative x minus 2 cubed minus 4. And we see that it intersects there. And you want to check this algebraically. So we have x minus 2 cubed minus 4 equals negative x minus 2 cubed minus 4. And is this always the case for any function? And conceptually, this is for a class discussion. Can you find any f of x such that f of x equals f of negative x? Hint, I already showed you this, but can you find this? And again, we'll leave that for a class discussion. And that completes this lesson.